Okay, recording now. This is lesson 10.4 on graphing linear relations. Before continuing to watch the recording, please make sure you have the 10.4 Graph Linear Relations worksheet in front of you. As well, make sure you have a pencil, a highlighter, and a straight edge. You may need a different colored pen as well, but you can keep that on hand. Now, if you need to pause the recording at all to grab any of those things, please feel free to do so. Just as a reminder, make sure that you're writing everything down as you see being written in the video. Now, as always at the beginning of most lessons, we have some vocabulary we need to familiarize ourselves with. So, take your highlighter, and the first vocab term you want to highlight is linear relation. So a linear relation is a new term for you this year, and that refers to a pattern made by two sets of numbers that results in points along a straight line on a coordinate grid. You actually informally dealt with linear relations last year when we were trying to figure out the pattern between x and y coordinates. As you can see in the example here, too, this would be one example of a linear relation where you have two sets of numbers here, and it results in a point on a straight line on a coordinate grid. Now, the next vocab word is pretty straightforward. It's a graph, and it is basically referring to a visual way to show how two sets of numbers relate to each other. Now, what I'll go over with you in this video is an example from your textbook, MathLink 7 on page 374. So this is a basic linear relation, and this is more of a straightforward one-step rule that you're going to convert into an algebraic expression as one way to describe the pattern. So I'll read you, and you can follow along what the problem is. So example 1, plot points and describe patterns. So Dr. Seuss often described patterns in unique ways. He once wrote about a pup in a cup and 3 fish in a tree. So the first step is to copy and complete the table. So the book has already assigned variables for the number of pups and the number of fish. So really, this is just another way of saying these are your x values, or I don't know if you guys can see, this is your input, okay? The number of fish, f, are your y values or output. Now, to be consistent with the problem that's presented, what they want you to use is p representing the number of cups instead of pups instead of x, and the number of fish is f instead of y. But really, you're thinking of it as your input and your output, if you remember from last year. So they've started off the number of fish for you here. If you only have one pup, you have 3 fish. The corresponding ordered pair is 1, 3. Now, as a reminder, this goes back to Unit 1 when we were dealing with coordinate planes. Remember, it's always the x value first before the y value. In this case, it's p, f, so it's x before y. If you have 2 pups, the corresponding number of fish is 6. So your ordered pair is nicely laid out for you. You have 2, 6. Now, you can probably predict the next number in the pattern. If you have 3 pups, the number of fish you would have would be 9. And go ahead and fill out the rest of the ordered pairs if you want to pause the recording now, and then check your answers with me after you finish filling out the chart. Number of pups is 4, number of fish is 12, so we have 4, 12. Finally, number of pups is 5, number of fish is 15, so we have 5, 15. Okay, so that is A for you. So we have the number of fish filled out and all of the corresponding ordered pairs. So the next step is to make a graph using the ordered pairs in our table. Okay, so as a review, think about all the elements that you need to set up your graph first. Okay, now remember that we would typically label the x and y axis first. I'm just going to put that way off to the side. In this case, though, instead of x, remember we're using number of pups as p, so I'm actually going to do that in red here because that's what the question's asking you to do. Hopefully that's not too confusing. And our output or y values is known as f, so I'm going to mark that with a red pen as well. Okay, now what's our scale going to be? We know that number of pups ranges from 1 to 5. Remember, that's our x-axis or horizontal axis. Okay, so we need to label our origin 0, and I'm just going to go up 1, 2, 3, 4, 5. Okay, so our y values or our f values, they range from 3 to 15. I could go up by 3s because it's actually nicely laid out for me here. So I'm going to go up by 2s though, so that it fills up most of our graph here. You can choose to go up by 3s if you want to, it doesn't matter. So I'm going to go 2, 4, 6. We know that our highest value, I think, is 15 on the y-axis or the output. Now, going back to our points here, I'm going to go back to pencil. So our first ordered pair is going to be 1, 3. I'm just going to plot the points, and then you guys can go ahead again if you want to pause the recording and just check your answers when you're done. Please feel free to do so. So 2, 6 is next, and then the next is 3, 9, in between 8 and 10. And then the next one after that is 4, 12. Again, if I'm going too fast, pause the recording and catch up. And then finally you have 5, 15. Okay. Now, okay, before moving on, let's just make sure we have our complete title for this graph. So let's just call it, for now, because we don't know what the relation is yet, we'll do number of pups versus number of fish. Okay, and just so we're clear, F is number of fish, and then on the x-axis we have number of pups. Okay, now you may also be wondering, well, how come we're not connecting the points here? So even though the points do fall into a straight line, so clearly you have a linear relation, the reason why you don't connect the dots here so you have a line graph is because in this case, because you're comparing, or you have number of pups versus number of fish, it's impossible to have 1.5 pups. It's also impossible to have 4.5 fish. Okay, here's another example. It's impossible to have half a pup. Okay, it's impossible to have 2.5 fish. So the idea is you only connect the straight line if you can clearly have the in-between values. In this case, you can't. You have to have a definite number of pups, so they only land on the whole number. Same with the fish. You can only have a definite number of fish. They have to land on the whole number. So that's why you don't connect the dots. Okay? Now, if we go back up to question C, C asks you to describe the pattern of points on your graph. And the book actually gets into 3 different methods. So this is part C. So we'll do method 1 first. Method 1 in describing the pattern. So the first method we're going to describe using words. So as we look and analyze our graph here, we can see that the points form a straight line starting at 1, 3. The F coordinate in this case is 3 times what the P coordinate is. If you look, for example, the first coordinate or ordered pair is 1, 3. 3 being the F value or the Y value is 3 times 1. So how do we jot this down in words? Well, the points form a straight line, so make sure you guys are jotting this down. Starting at 1, 3, and then the F coordinate or output is 3 times the x-coordinate. Or sorry, the p-coordinate, or input. Oops, input. Okay, so method 2 in describing the pattern, you may think this is pretty lengthy, but you have to be familiar with all 3 different methods, is describing using the horizontal and vertical distances. Okay, so what I mean by that, if you look up here, let's just do this in a different color here. Okay, so if we look at the distance between these 2 points, we can see that you're going, okay, from this value to this value. Remember, we always deal with the horizontal distance first. You're moving 1 unit right, okay, and then you're moving, so you're still at 3 here, and you're going actually 3 units up. So you're going from 3 to 4. So again, you're going 3 units up. So you're going from 3 to 4, 4 to 5, and 5 to 6. So really, you're moving 1 unit this way, and you're moving 3 units up. Okay. So how do we describe that using horizontal and vertical distances? It's like we're doing a translation. So the points increase, three units, or sorry, that should be 1 unit. Increase 1 unit to the right, and 3 units up, starting at 1, 3. Okay, finally method 3 in describing the pattern. So I'm going to have to extend my page here. 1 second. Actually, to avoid extending my page, I'm just going to put method 3 up here because this is actually the one that you really want to focus on in describing patterns. And that is describing using a relationship. So in other words, we're going to describe this relationship between the number of pups versus the number of fish in an algebraic way. So we're going to use an equation. So remember that we're dealing with the variables f for fish and p for pups, okay? So I'm going to go back to the t-table up here. Really, if we think about what the rule is, going back to what it is, right? Really, what do we do from x to get to y? We multiply by 3, right? What do we do from x to get to y? We multiply by 3. What do we do here to get from x to y? We multiply by 3. Okay, so really, what are we doing to the input? To get to the output, we multiply by 3. Okay, so really our rule is times 3. Okay, so keep that in mind. Now, what may get confusing is that the variables here are different. Okay, so our y, or our output, in this case, is actually the variable f, right? Our input, or our x, is actually the variable p. Okay, so we want to describe the relationship in terms of f and b. So remember, f being the output, p being the input. So to get from p to f, we have to multiply the input by 3. Therefore, f equals 3p. Okay, so I'm going to repeat that again. This is what the relationship is in describing what you have to do from the input to get to the output. In other words, we have to multiply the input number by 3 to get the corresponding output value. Okay, and that's it.